Hello. At this video, I will show you the experiment and brief theoretical background of the charging and discharging of a capacitor in an RC circuit. Let me define first the capacitor. Capacitor stores electrical charge. It's not the same as the battery. A capacitor uses two metal plates separated by an insulator, and it basically stores charge by taking electrons from one side and pumping it towards the other side. The insulator here can be air, paper, water, or anything which does not conduct electricity. Here, the equation gives us the charge in coulomb, which is equal to the multiplication of capacitance and voltage. Here, the charge is in the unit of coulomb. Capacitance is in the unit of farad, and voltage, as you know from the previous experiments, is in the unit of volts. When a capacitor with a capacitance of C is charged through a resistor of R at a fixed voltage of V, the relation of current and voltage with the time will be like that. So, this circuit diagram shows us the situation of charging of a capacitor. And also, here, this multiplication is called as time constant and is shown by tau. This property is also important for capacitors. We will see in the experiment. What if we reverse the situation for the capacitor to discharge? As you can see easily from the circuit diagram, the stored energy, I mean the electrical charges, will be dissipated by the resistor until all the charges are used through the circuit as a flowing current. And here, the equations for current and voltage across the capacitor is given like that. So, this situation is for discharging. And using these equations, we can easily calculate the theoretical value for current through the circuit and voltage across the capacitor. If we plot charges versus time graph for both situations, I mean charging and discharging, the curves will be depicted as shown in the graph. Since there's a linear relation between the charge and voltage, we assume that this graph as a voltage across the capacitor versus time graph. In this graph, we see that a plot of voltage versus time constant. And here, it is obviously seen that when the time is equal to the 1 tau, the voltage reaches the value of approximately 63% of the final voltage value for capacitor. And if we keep going on the time axis, we see that at 2 tau, capacitor's voltage reaches approximately 86% of the final voltage value. As you see respectively, see on the time axis, at 5 tau, a capacitor is almost fully charged. Now, let's build the experimental setup and find these values by using multimeters.